Hello everyone, good afternoon. Welcome to the final session of Csat Quantitative Aptitude. Okay, so this is the final session of this lengthy series. Okay, 23rd lecture. We have completed 22 so far, and the prominent portions of the Csat is already done. Okay, but this one is also very important. Always, I think literally in every Csat paper, there are a couple of questions from this part: odd man out or series. Okay, from either of those. Either you will be given, say, five or six numbers, and you would be asked to pick out the odd man out from that, or you would be given like five, six numbers, and you would be asked to find a missing term or something like that. One of these or both of these will always be there in every CSAT paper, not just for CSAT. This is same for SSC, PSC, all kinds of examinations. This is one common area that always comes in an exam. So it is very, very important. Okay. So once again, I welcome you to Madhav Sankar classes. If you haven't subscribed, please do subscribe. And please like this video, share with your friends. And without any further ado, let's begin this session. Okay. So this is the final lecture of CSAT series. The environment lecture is ongoing. And we have completed 19 lectures there so far. We will finish it by the end of this year. Okay, I will announce the class dates in the Telegram channel. Please follow that channel for updates. So there is nothing to learn as far as this area is concerned. Basically, the only way to improve on this topic, odd man out and series, is to try and maximize your attempts. Okay, try to solve as many questions as possible. Only then you will get speed. Only then will you able to identify a pattern immediately. Okay, when you see a group of numbers, say for example 2, 4, 6, 8, dash 12, 14. When you see this immediately, you know that this is a series of even numbers. Correct? So you will get the answer as 10. Why? Because you are very familiar with this pattern. Similarly, other patterns can also be there. Correct? And in order to recognize them very quickly, you have to practice more and more. There is no shortcut for this. Nobody can teach you how to look for something, because pattern can be based on anything. Correct? But so try to do more and more questions so that you will understand how these patterns are usually kept in the examination. So you will be immediately able to relate with it and get the answer. Okay, so let's start with some easy questions. Find the odd man out. First question, find the odd man out. 3, 5, 7, 12, 17, 19. Which among these numbers does not fit the sequence? Those live viewers, kindly try to answer these questions. I will give you some 10 seconds for each question. Please do try to answer it, and I will tell how to how to find out each of these answers. Okay, 3, 5, 7, 12, 17, 19. Which one would be the odd man out? If you get the answer, please put it in the YouTube live chat. Okay. Any idea? Any guesses? So this is actually pretty simple. This is the first question. So I kept it very simple. 3, 5, 7, 17 and 19. Basically, these are the initial prime numbers. Okay. Keeping 2 apart. If you look at it, 3 is a prime number. 5 is the next one. 7. 17, 19, all these are prime numbers except 12. 12 is not a prime number. Okay, so 12 is the odd man out. Got it? So again, for someone who has regularly practiced these kinds of questions, this would take like 1 second maximum. Immediately that person would be able to recognize that 12 is the answer. All right, so please try to do as many of these questions as possible. Another one, there are some 15 questions I have taken from various series, and that's all we are going to do today. Okay, second one, 1, 4, 9, 16, 23, 25, 36. Please try to answer this. I'll give you 10 seconds. Those live viewers, please try to answer it. Another very simple series. find the odd man out from the following numbers. Okay, so what's how to find the answer here? 1, 4, 9, 16, 23, 25, 36. Basically, this is what? 1 square, 2 square, 3 square, correct? 4 square, then comes 23, then 5 square, 6 square. So which is the odd man out? Odd man out is 23. Correct? 1, 4, 9, 16, 23, 25, 36. These are very simple series. If the moment you look at it, you will get the answer. Correct. Next one. 8, 27, 64, 100, 125, 216, 343. Try to identify the odd man out from this series. Again, think in the, we have did 2 questions so far. So based on that, try to work this out. These are all related questions. So you should be able to see a pattern here. What are the common patterns? Odd numbers, even numbers, correct? Prime numbers, squares, cubes, correct? These are the most common patterns that we see in these kinds of questions. So try to check if any of those fits first. If not, then try to find some relationship between adjacent terms. So here, what is the question? 8, 27, 64, 100, 125, 216 and 343. So 8 is what? 2 cube. 27 is 3 cube. 64 is 4 cube. 100 is what? Nothing. Okay, it's not a cube of anything. 5 cube is 125. 6 cube is 216. And 7 cube is 343. So the answer is 100. Okay, so 100 is the odd man out. Another one. 1, 5, 14, 30, 50, 55, 91. Alright, now I'm going to give you some tricky questions. The first 3 were very simple. You could find out the answer in seconds. Try solving this one. 1, 5, 14, 30, 50, 55, 91. When you get these kinds of series, if you cannot immediately find out the answer, or if you cannot immediately get a particular number, then try to find relationships between adjacent terms. Okay, so I will rewrite this. 1, 5, 14, 30, 50, 55, 91. Alright, now we are going to find out some relationship between the adjacent terms. What is the difference between 1 and 5? 4. Correct. 5 and 14, 9. 14 and 30, 16. 30 and 50, 20. 50 and 55, 5. 55 and 91, 36. Correct. So if you look at this closely, you can see that this is basically 2 square. This is 3 square, 4 square. So if this pattern is supposed to carry on likewise, then it should be 5 square here. So instead of 5 square, it is 20. Correct. So if we take this 50 out, then 30 plus 5 square is 55. So that is given. Then we have 6 square and so on. So that sequence is completed. The pattern is correct. So 50 is the error term, odd man out. So answer is option B. Okay. So immediately, if we cannot recognize a particular pattern, try to find out relationships between the adjacent terms. It may not always work, but it is one of the first steps that you can proceed with. Okay, another one. 385, 462, 572, 396, 427, 671, 264. Okay, first of all, when you see these kinds of questions, do not get panicked. Alright, because there is no logic in these kinds of arrangements, correct? The first term is in the 300s, then 400, 500, then again 300, then 400, then 600, then 200. So that it makes no sense. Correct? But all these are 3-digit numbers. That is one of the things that you have to recognize. When you look at a question, try to, do not take anything for obvious. Try to see each fact as given. All right. So here there is no, recognized pattern between these numbers. Correct? So that is a fact. Keep that in mind. Second one, all of them are 3-digit numbers. Correct? Some are odd, some are even, but all are 3-digit numbers. So that should have something to do with the question. It cannot be completely random. Okay? The first point also, there is no relationship between any of these numbers, which means that number by itself should have some sort of pattern. That number by itself should be, some particular arrangement. 385. Okay, 385. 3 plus 5 is equal to 8. 462. 4 plus 2 is equal to 6. 572. 5 plus 2 is equal to 7. 396. 3 plus 6 is equal to 9. 427. 4 plus 7 is equal to no. So this term does not fit the pattern. Let's check the other ones. 671. 6 plus 1 is equal to 7. And last one, 264. 2 plus 4 is equal to 6. Got it? So the only term that does not fit this pattern is 427. So that is your answer. Got it? So it is, all these are 3-digit numbers. So there should be some ideology behind that. There is no logical correlation between any of these terms. So from these two, the thing that you have to think, or you have to detect, is that individual terms have their own patterns or some specificness, some uniqueness about it. Got it? So by using that kind of thought process, we arrived at the answer 427. Another one. 19, 28, 39, 52, 67, 84, 102. All right. So here also, I'll give you some 10 seconds before I answer this question. Think about it, okay? So 19, 28, 39, 52, 67, 84, 109. This is in ascending order. Correct? So there is some sort of relationship between these terms. There is something that, that is common to all these. It's not like the previous question. That is for sure. Okay? There is a pattern here between these terms. So try to find out. Try to connect these with some of the common patterns that we know. Okay, odd numbers, even numbers, prime numbers, squares, cubes. Try to connect these things with that. Try to find a relationship between those. Is it possible? In all cases, it may not be possible, but try in this question. 19 is equal to, first term, 16 plus 3. Correct? 28 is equal to 25 plus 3. 39 is equal to 36 plus 3. 52 is equal to 49 plus 3. 67 is equal to 64 plus 3. 84 is equal to 81 plus 3. 102 is equal to 99 plus 3. Okay, so this is basically 4 square plus 3, 5 square plus 3, 6 square plus 3, 7 square plus 3, 8 square plus 3, 9 square plus 3. So here it should be 10 square plus 3. But there is no 10 square. It is not 100 plus 3. It is 99 plus 3. So this one does not fit the pattern. So your answer is 102. Alright. So when you get these kinds of series, where you cannot immediately see that relationship, try to connect that series with certain other series that you are familiar with, like the odd series or the even series or the prime series or the Fibonacci numbers or anything like that. Any common series that you know about. Try to see if this series is somehow related to that one. Okay, that is another way of solving this kind of questions. All right, so let's try another one. 253, 136, 352, 460, 324, 631, 244. Here also, remember what I said about these kinds of questions. All of them are 3 digits. That is the first thing I noticed. Okay, second thing I noticed is there is no logical arrangement of any of these terms. Here it is in 200s, then hundreds, then 300, 400, again 300, 600, 200. No logic between those terms. So there should be something unique about each of these terms. Okay, there is no pattern in that, it's not a series, but there should be some properties of that number that makes that number eligible to be a part of this sequence. So 2, 5, 3. 2 plus 3 is 5, so that works. So it could be one of the things, but that does not work for this. 1 plus 6 is not 3. Say, let's try another one. 3, 5, 2. 3 plus 2 is 5, that works. But 4, 6, 0. 4 plus 0 is not 6, so that doesn't work. So it's not the case. What else could be the case here? Think about it. Okay, once you do more of these questions, you will easily be able to identify this. Here, the thing is 2 plus 5 plus 3 is equal to 10. 1 plus 3 plus 6 equal to 10. 3 plus 5 plus 2 equal to 10. 4 plus 6 plus 0 equal to 10. Sum of the digits in each of these are equal to 10. That is the pattern here. Try another one. 324. 3 plus 2 plus 4 equal to 9. 631. 6 plus 3 plus 1 is equal to 10. And finally, 244. 2 plus 4 plus 4 equal to 10. So which one does not fit the pattern? 324. Did you understand? So keep this in mind. Try to see if there is some sort of arrangement. Okay, some sort of a series progression happening, ascending or descending, or some sort of relationship between those terms. If there is no such relationships, then there is a very good chance that that individual term could have some properties that merits it to be a part of that sequence. Okay, so moving on. Find the wrong number in the sequence. 36, 54, 18, 27, 9, 18.5, 4.5. Okay, so here 36, then it goes to 54, so it goes up, and then it comes down, again goes up, again comes down, again goes up, again comes down. So there is a pattern. Okay, there is a relationship between all of them. It's not very random. It's like going up, coming down, going up, coming down, going up, coming down. So some sort of pattern do exist. Okay, so try to find out the relationship between adjacent numbers. I will rewrite this. What is the relationship between 36 and 54? 36 plus 18 is 54. Yes. But 54 plus 18 is not 18. Similarly, 18 plus 18 doesn't make 27. But 18 plus 9 makes 27. 27 plus 9 doesn't make 9. Correct? 9 plus 9.5 makes 18.5. Correct. So that does not make too much sense. What other relationship could be there? In certain kinds of series, especially when this series is like, increasing and decreasing and increasing and decreasing, such extreme patterns are there. There will be two kinds of relationships, minimum. Okay, it's not constantly ascending or constantly descending. It is ascending then descending, ascending, descending, ascending, descending. So two relationships will be there, minimum. So 36 into 1.5 or 3 by 2 is equal to 54. 54 divided by 3 is 18. 18 into 1.5 is equal to 27. 27 divided by 3 is equal to 9. 9 into 1.5 should be what? 13.5. Okay, so here it should have been 13.5. If that was 13.5, then 13.5 divided by 3 would give you 4.5. So that is the pattern. Into 1.5 divided by 3. Into 1.5 divided by 3. Into 1.5 divided by 3. Okay, so the term that does not fit here is 18.5. So your answer is option C. So whenever you get such series, when there is, there is a pattern, but there is increase and decrease and increase and decrease, so on, please understand that there should be at least two kinds of relationships there. It's not simply multiplying one by one constant or adding a constant or anything. It should be like adding something and then decreasing something. So minimum two kinds of operations are happening. Okay, another one. Find the wrong number in the sequence. 4, 9, 19, 39, 79, 160, 319. Any ideas? Here also, look, when you look at it, there is some sort of a arrangement. Okay, that it's continuously increasing. 4, 9, 19, 39. Correct. So it is not like the previous one, which is alternating or anything. So there is some sort of continuous pattern, and it's continuously increasing. So there is something. What exactly is that? Try to find out the relationship between the adjacent numbers. 4, 9, 19, 39, 79, 160, 319. What could be the relation? What is the relationship between 4 and 9? It is 5. 9 and 19, 10. 19 and 39, 20. 39 and 79, 40. 79 and 160. What is the relationship between 79 and 160? It is 81, correct? 160 and 319. What's the relationship here? That is not 160 minus 1. That is 159. Okay, so 5, 10, 20, 40. So basically, 5 into 2 is 10, 10 into 2 is 20, 20 into 2 is 40. So 40 into 2 here, it should be 80. Correct? In which case, what should be the number here? It should be 159. And this into 2, 159 into 159. Into 159 plus 159. That would be the next one. Correct. So here the term that does not fit is actually 160. Alright, there is another relationship also. You can solve this in another way. 4 into 2 plus 1 equal to 9. 9 into 2 plus 1 is equal to 19. 19 into 2 plus 1 equal to 39. 39 into 2 plus 1 is equal to 79. So 79 into 2 plus 1 is equal to, what should be the answer there? 159. But it is written as 160. So that's the wrong term. Okay. Then 159 into 2 plus 1 equal to 390. So that fits. So the wrong term is 160. Got it? Next one. Insert the missing number. So instead of finding the wrong number, you will be sometimes asked to fill up the blank. These kinds of questions were asked in UPSC this year also. So try to find this one. 5, 10, 13, 26, 29, 58, 61 and blank. So using the given numbers, try to identify a pattern and then find the number that will fit that pattern. That's how you solve this. So what is the relationship between 5, 10, 13, 26, 29, 58, 61? And what would be the next number? Think about it. 5 into 2 equal to 10. 10 plus 3 equal to 13. 13 into 2 equal to 26. 26 plus 3 equal to 29. 29 into 2 is 58. 58 plus 3 equal to 61. So accordingly, if this pattern is going on, the next one would be 61 into 2, that is 122. Correct? Into 2 plus 3. Into 2 plus 3. Okay, so when you are given these kinds of questions where you are supposed to find a missing number, try to use the remaining number to find out a pattern. It will not be too much complicated. Okay, it's basically the same thing. There could be some relationship between the standard patterns like odd number, even number, prime number, etc. Otherwise, there should be some relationship between the adjacent terms. Find that out, decode it, and work it out. But do at least consider the relationship between 4 numbers. We need minimum of 3 to establish a relationship. Okay, say if I look at it like this, say 5 into 2, 10. 10 plus 3, 30. So there is no pattern. If I stop there, then I won't be able to see that full pattern. So minimum, try to find the relationship between 4 numbers. So 3 relationships has to be there before you give up a thought process. Okay, so here 5 into 2, 10, then plus 3, 30, then into 2, 26. So it's again repeating, then again plus 3. So because I considered the relationship between at least 4 numbers, I got a series. So the point is, do not, stop looking at it in a particular way just because the first 2 and the second term does not fit. Try to see at least 3 or 4 relationships before you give up a thought process. Okay, next one. 16, 33, 65, 131, 261, blank. Any idea? Here also, there is a constant process. It is ascending. Okay, this is a purely ascending series. So there is some sort of relationship. Also, see, since there is nothing obvious, please try to see the relationship between each of these terms. 16 and 33. What is the relationship? 16 plus 16 is 32 plus 1. Correct. Then 33 and 65. 33 plus 33, 66 minus 1. 65 and 131. 65 plus 65, 130 plus 1. 131 and 261. 130 plus 131 plus 131, 262 minus 1. So basically, this is into 2 minus 1 plus 1. Then into 2 minus 1. Into 2 plus 1. Into 2 minus 1. So here it would be into 2 plus 1. So 261 into 2 is what? 522 plus 1, 523. Got it? By this, using these sorts of techniques and methods, you have to practice as many as possible. Okay, so that when you see the series itself, you will be able to recognize it. You may not have to think so much. The thing that with these kinds of questions are, in an examination scenario, you would want to solve this. So you will spend time with these questions. Even if you do not get it immediately, you will definitely waste time on it. Okay, these are, the kind of questions that would attract your attention and, catch your interest. So you would sit there and try solve these kinds of questions. So there is a very good chance that you would waste a lot of time here. So make sure that it does not happen by training your brain to recognize various kinds of patterns. Alright, plenty of questions are available in this format in the internet. Download them, practice at least 5 or 10 in a day. If you can practice 5 questions of identifying patterns per day, no pattern would be of surprise for you in the examination. Okay, another one. 3, 7, 6, 5, 9, 3, 12, 1, 15, dash. Any guesses? Okay, the options here are wrong. All right, I'm sorry for that. So in the series, look at it. 3, 7, 6, 5, 9, 3, 12, 1, 15, blank. So first of all, if you compare this with the previous questions, you can identify that the number of terms given are very, many. Okay, here 1, 2, 3, 4, 5, 6, 7, 8, 9 terms are given and then a blank. Here only 5 terms are given and blank. Here also 6 or 7 terms and blank. So here there are plenty of terms. So there should be something else here. It should not be very that obvious, or it should not be like the previous ones. There is a reason for these many numbers to be given. And usually that reason is there are 2 series here. Okay, whenever too many numbers are given, please consider the possibility of 2 series or multiple series. Consider this one. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. And it goes on. Correct? So this is a series by itself. Consider the other series. 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 1 is 3 minus 2 is 1. And 1 minus 2 should be minus 1. So the answer is actually minus 1. Because there are 2 individual series here. Got it? So whenever the number of terms given are very high, consider the possibility of multiple series. Okay, and then once you identify it, then it would be very, very easy. Do not try to consider the relationship between adjacent terms or anything, because that doesn't work. Here it is 3 plus 4, 7, then minus 1, then again minus 1, then plus 4. It's completely confusing. You would waste a lot of time. Okay, next one. Oh, sorry. Yeah, this was actually the question. Yeah. Sorry for that. This is basically that question. I repeatedly put the same question. So the answer to that one is minus 1. Okay. Another one. 165, 195, 255, 285, 345 blank. So this is not like the odd man out. Okay. If this were the odd man out, then you know how to solve it. But here you have to find the missing number. So all these numbers are correct. There is some sort of relationship between these numbers. Also, all these are 3-digit numbers. So that is one observation that I made. Second observation I made is, this is in an ascending series. 165, 195, 255, 285, 355. So it's not like random. Okay. So there should be some relationship with a specific series. These terms are somehow related. Another observation that I made from this series is that all of them are divisible by 5. All of them ends with 5. Correct? So all are divisible by 5. Another observation that I could make out of this is all are divisible by 3. 6 plus 5, 11 plus 1, 12, divisible by 3. 1 plus 9, 10 plus 5, 15, divisible by 3. 2 plus 5 plus 5, 12, divisible by 3. So all these terms are divisible by 3 and divisible by 5, which means all of them are divisible by 15. I hope you remember the first Csat class where I talked to you about divisibility. How to check for divisibility. Correct? So using that, 165 divided by 15 is what? 11. 195 divided by 15 is equal to how much? 12 is 180, so 13. 255 divided by 15 is equal to 17. 285 divided by 15 is equal to 19. 345 divided by 15 is equal to 23. Correct? So 11, 13, 17, 19, 23. All these are prime numbers. So what comes next? After 23, the next prime number is 29. So what is 15 into 29? 15 into 29 is 435. Got it? So that's how you do it. Observe that pattern. See whatever information you can get from that. All these are 3-digit numbers. All these are divisible by 5. All these are divisible by 3. And there is a constant ascending progression. Using all these observations, you can find the answer. Okay, similarly, another one. 125, 106, 88, 76, 65, 58, 53. Find out the wrong number. Okay, you have to find the wrong number. Which one does not fit the pattern? Okay, so 125, 106. If any of you want to try this out yourself, please pause the video here and do it in your own speed. Okay, but I'm going to solve this. 125 and 100. So here also there is a constant relationship. It's continuously descending. Okay, so the divisibility and all does not work here. It's ending with different numbers, and some are even, some are odd. Not everything is divisible by any common number. Okay, so nothing like that. So how do we proceed? The next thing to check is the relationship between adjacent terms. So 125 and 106, what's the relationship? 106 plus how much is 125? 19. Correct. Now 106 and 88, what is the relationship? 88, 98, 8. So 18 is the relationship. 76 and 88, what is the relationship? 12. 76 and 65, 11. 65 and 58, 7. 58 and 53, 5. So if you look at this pattern, 5, 7, 11, all these are prime numbers, 19 also. So the terms that are not fitting here is 18 and 12. Correct. Instead of 18 and 12, we could have, if it were like 17 and 13. Then this will make sense, because this is the series of prime numbers. 5, 7, 11, 13, 17, 19. These are the prime numbers, correct? So what should be the term here? Instead of 88, it should have been how much? 89. If it were 89, then this series would fit. So the wrong one is option B. Understood? Another one. 1, 2, 8, 33, 148, 760, 4626. Wow. That increase is very drastic. Correct? So whenever you get a series like this, where that, it's an ascending series. Okay. So there is some sort of relationship. But when that, that increase is so drastic, consider the possibility of having a relationship with squares or cubes or something like that. Okay. When that terms start to increase or decrease in a very drastic pace, you have to understand that there could be a relationship of that series with squares or cubes. Very high chance. All right, so let's see this. First one, okay. 1, sorry. My pen got stuck. 1 minute. Yeah. So 1, then 2, 8, 33, 148, 760, 4626. So what is the relationship between 1 and 2? 1. 2 and 8, 6. 8 and 33, wow, 25. 33 and 148. What is the relation between 33 and 148? 8 minus 3, 5. 14 minus 3, 11. So this is making no sense to me. Correct. So try to relate this with squares or cubes. Okay. So let me try to relate this with squares. 1 and 2. How do you relate this with the square? 1 plus 1 square is 2. Correct. Then 2 and 8. 2 and 8. 2 plus 2 square is what? 6 only. Correct. So it's not working. So 2 into 2 plus 2 square. That is 8. Correct. So into 2 plus 2 square. I am erasing the above line to make it more clear. Okay. Okay. 2 into 2 plus 2 square is 8. Now 8, if I am going to try this out, then 8 into 3 plus 3 square. Correct. 8 into 3 is 24 and plus 3 square, that is plus 9 is 33. That works. Into 3 plus 3 square. So similarly, into 4 plus 4 square. into 5 plus 5 square into 6 plus 6 square. This is the series. Here into 1 plus 1 square. That works. Okay, but let's check this out. 148 into 5 is what? 148 into 5 is 740 plus 5 square is 765, but it is only 760. Okay, so the error term is 760. This is the wrong term. Otherwise, it fits the pattern. So whenever you get a series where there is something like, such drastic increase in a number, then consider the possibility of squares or cubes or, such high levels of multiplication within that series. Okay, once you train your brain to identify these, all this will be very, very easy for you. Right now, you might think, oh, in an examination point of view, I might never think of this sort of relationships. But once you have done enough questions, your brain will automatically find that link between all these things. Try doing 5 of these questions every day. That's all. 5 of these, missing terms or odd man out series. These are interesting also. Doesn't take too much time. These are interesting. So you won't get bored. Okay, last question for the day. 888, 440, 216, 104, 48, 22, and 6. So what is the relationship? Here is again, this is a descending series. That is my first observation. Second observation is here also there is a decrease. Okay, there is a huge decrease. It's not a small decrease. It's not like 888 and 880 and 840, 820, 800. No, it's not like that. It's like skipping down quite some steps, but not like squares also. In the previous question, the increase was so much. Correct. Here the increase was over 100. Here it was over 600. Here it was over 4,000. Correct. So that was huge. But here it's not that huge, but it's not like your common small difference either. So usually this kind of series have something to do with division. Also see these terms: 800, 400, 200, 100. So these are halves. It's going by half. Correct. So from that, I know that this series has something to do with dividing by 2. Okay, it's because it's halving after each of these terms. So something to do with 2. But what exactly is it? That's the question. Let's rewrite this series. 888, 440, 216, 104, 48, 22, 6. So what is the relationship? 888 and 440. 888 divided by 2 is 444, but it is only 440. Correct. So if it has to be 440, then I have to subtract 8 here. So 888 minus 8, so 880 divided by 2, that is 440. Correct. So let's try that out. Minus 8, then divide by 2. Okay, so 888 minus 8 is 880 divided by 2 is 440. Does this work? 440 minus 8, 432 divided by 2, 216. So that is working. 216 minus 8, 208 divided by 2, 104. Yes, that's the series. 104 minus 8, 96 divided by 2, 48. Correct. So 48 minus 6, 42 divided by 2 should be 21. It is not 22. So if this series is supposed to be followed, it should be 21 here. 21 minus 8. How much? 13. Okay, divided by 2, it should be 6.5. Correct? Did I make a mistake somewhere? No, right? So this is the error term. Because of this error term, this series is not fitting. Otherwise, it's not. This is a perfect series. Minus 8 by 2. Did you understand this pattern? Similarly, you can identify such patterns in almost all kinds of these questions. But some of the things that you have to keep in mind are the ones I mentioned throughout the series. First of all, try to see if it has something to do with standard series. Odd number, even number, prime numbers, squares, cubes. Okay. Also, try to see do not take anything for obvious. Try to see what's given. Maybe that there is no logical sequencing of those numbers, but those numbers themselves could be having some sort of unique properties, like that 3-digit numbers that we did. See if that pattern is uniformly increasing or uniformly decreasing. See how many numbers are given in that series before you are asked to find a missing term. If you are given too many numbers, there is a very good chance that there could be more than one series within that sequence. Okay, similarly, if that series is increasing or decreasing drastically, then there is a good chance that it has something to do with multiplying by squares, multiplying or adding by squares or cubes. If there is no drastic decrease or increase, but still there is substantial increase or decrease, there is a good chance that it has something to do with multiplication or division. Okay, so keeping all these things in mind, try to do more and more questions. The only way to be better in this area of CSAT is to do more questions. There is no tips or tricks, because I can create hundreds of series having different kinds of logic. If you have to match it, then your brain should be trained for that, because each of them have unique properties, correct? Each of them have unique relationships. It's not like the previous chapters, like pipe and cistern or boats and streams or train and time. There we know how to proceed. There's a unique way in how to proceed. Here that's not the case. Here I gave you some fundamentals. I gave you how to recognize these patterns, but that doesn't mean you will be able to do that unless your brain is ready to do that. So you have to work this out yourself more and more. That's the only way you can master this area. So please do that in your time. And that's it. We have completed the entire quantitative aptitude series for CSAT exam, and we are winding up this series here. Thank you all for joining. To all of you who have completely watched this series, I think there is only 1 or 2 people who have been live in all my sessions. To that person, whoever it is, thank you. Please do ping me personally in WhatsApp or Instagram if possible, just to get some feedback, that's all. And I will upload the class notes into the Telegram channel. And like this video, subscribe to my channel and share with your friends. Okay, so until next time, bye bye.